Hello everyone. In this short little video, we will be estimating the radius of the Earth, or actually studying a simple technique for estimating the radius of the Earth. Now for this estimation, what you have to do is, you have to go to a place which is close to the equator and ideally get to a beach front which faces the west direction so that you can see the setting sun. Now what you do is you lie down on the beach, lie down flat on the ground on the beach and look at the setting sun. And the moment the sun sets completely, you get up and start your stopwatch. Now as you get up, your eye level comes up to a height h above the ground, and from this raised eye level you can actually see the sun for a little while. Now since you have a stopwatch on, you can actually calculate, or you can actually see from the stopwatch as to how long the sun remains visible again after getting up. Now let's say you get a time reading of t second from your stopwatch. Typically this would be just a few seconds, maybe 3, 4 or 5 seconds, no more than that. So this stopwatch will give you a time of just a few seconds. Now even after getting up, you're able to see the sun only for a few seconds longer. Now based on this reading of time, which I have taken as t second, we can actually estimate the radius of the Earth. Now when we are on the ground, when we are looking at the Earth from our perspective while we stand or sit on the ground, the Earth appears to be flat. Now if we are at point A, the Earth appears to be flat because if we draw a tangent here, when we are at point A, we can only see points on the Earth which are very, very close to point A. And since the radius of the Earth is very, very large, we see a very tiny fraction of the surface of the Earth, which then appears to be flat. Now if I draw this tangent here on the surface of the Earth, and when we lie on the ground at this point, we can see everything above this tangent plane and nothing below it. Now the moment the sun sets, it has actually gone below this tangent plane. Now we were lying here on the ground and the sun has just gone below the horizon. We start the stopwatch and get up, which brings our eye level to a height h above the ground. Now from this raised eye level position, we can actually see the sun. But then the Earth is rotating in this direction. And as the Earth rotates, eventually we reach point B where our eye level goes below this tangent plane. And we can no longer see the sun again. We have made the assumption that this process takes a time t. So in time t, we reach from here to here, where the eye level goes below the tangent plane and the sun is no longer visible to us. Now we know that the Earth rotates a total angle of 2 pi radians in a time of 24 hours, which is 86,400 seconds. So on a per second basis, the Earth rotates 2 pi by 86,000 radian. So if the Earth rotates 2 pi by 86,000 radian per second, then in t second, the angle rotated by the Earth will be 2 pi into t by 86,400. So we figured out this angle theta by which the Earth rotates for the sun to go invisible again. Since this theta and this time t are both very, very tiny quantities, they are very small numbers, we can make the assumption that tan of this theta, tan theta, will be equal to theta itself. Now, if you look at this triangle here, OAB, in this triangle, AB divided by AO is your tan theta, which is approximately equal to theta. Now, AO equals R, and therefore AB by R equals theta, and AB therefore becomes R times theta. Now, if you look at this right angle triangle, AOB, it's a right angle triangle, and therefore we can apply Pythagoras' theorem. AB square plus AO square equals OB square. AB square plus AO square equals BO square. And therefore AB is R theta square plus R square plus R plus H whole square. Now once you expand this bracket, you get R square plus H square plus 2RH. R square cancels. R square theta square equals H square plus 2RH. And here we can actually neglect H square, because H square in comparison to this term will again be very, very small, very, very tiny, because this term involves R, the radius of Earth, which is very large in comparison to H. And therefore H square can be neglected. And finally we have R square theta square equals 2RH. The R here again cancels, and we have R equals 2H by theta square. And theta we had already estimated. We substitute the square of theta here, and we get this value for the radius of the Earth. This is the magnitude of the radius of the Earth. Now I suggest you actually try this out, especially if you live somewhere near the equator. You can try this out, and you will definitely arrive at a fairly reasonable estimate, perhaps something like 6,000 kilometers or so, if you perform the experiment at a place close enough to the equator. Thank you very much for watching this video.